In this session, we are going to perform a swept path analysis using the AutoDrive bearing tool. As you can see, I have a drawing open on screen. If we look at the top of the interface, we can see the drawing is called 02 AutoDrive bearing. I'm going to zoom in on the center of this file. Right here is a parking lot that represents a fast food restaurant. Let me zoom in a little bit closer on the north side. What I'd like to do in this session is use the vehicle tracking tools to verify that a garbage truck traveling east along this frontage road can successfully make the turn into this parking lot and then back up to the dumpster enclosure. I'll start by selecting the vehicle tracking tab to bring those tools up on screen, and then I'll click the AutoDrive Arc tool. When the library pops up, I'm going to drag down to the bottom, and if I expand the group representing this drawing, we can see that I've already included some vehicles in this file. To select the refuse vehicle, I'll double click on it. I'll click OK, and then I will click to place the vehicle in the drawing, and I'll align it to the curb. I'll click Proceed, and then I can drive the vehicle into the parking lot. Now, since I selected the AutoDrive Arc command, I am driving this vehicle using curves. I don't have to, though. I can also drive using a selected bearing. To do that, I will pull over to the AutoDrive dialog box, and I'll choose the Turn Onto Bearing option. When I do, as I pull my cursor away, you can see I am creating an immediate turn in the direction of my cursor. This works in both forward and reverse. Using this option is a lot like drawing a line segment in AutoCAD. That is because I am currently using the freehand method where I'm turning immediately. I can also turn through a specified angle. Let me select that option, and you can see that I am now turning through a 90-degree angle. Using this menu, I have other angle choices. As an example, I'll choose 45. You can see I'm now turning on a 45-degree angle. Probably the most helpful option is the picked alignment method. If I choose this, I can use the geometry in my drawing to help me identify my turn direction. In my case, I would like to drive into this parking lot such that I'm parallel to the parking lot. So I will select the sidewalk geometry to represent my direction. I can then pull into the parking lot, and I'd like to back up to the dumpster. Once again, I'll use pick alignment. I'll zoom in and I'll select the curb line to define my direction, and I'll back up to the middle of the enclosure. When I'm finished, I'll right-click and press Escape. Now let's back up and take a look. The path looks pretty good, with the exception of right here at the beginning of the turn. I'm clipping across the island. Not a problem. We can easily correct this using grips. Since this path was drawn using the bearing method, if I select the path, you'll see some additional arrow grips, one here at the beginning and one at the end of the curve. These arrows represent overturn. To correct the path, I'll click this first overturn arrow, and I'll pull up. This causes the driver to steer left slightly before they turn right, giving us a little more room to get into the parking lot. Now that I've pulled that out, I'll click Escape, and we'll take a look. Looks pretty good. So as you can see, using only a couple clicks, we can easily verify that this vehicle can perform the desired maneuver. Now that we understand how to drive a vehicle using the AutoDrive bearing tool, I'd like you to use the tool to complete another swept path analysis. Let me pan the drawing over. Over to the east, we have some geometry representing a small shopping center. I'm going to turn on a layer. I'll do that by going to the Home tab, and then here in the Layers panel, I'll open the Layer Control, and I'll turn on this layer called Instructions. What I'd like you to do is verify that a WB-40 intermediate semi-trailer can start at point A, drive back through the employee parking lot, and then park in this bay labeled B. Now, just like before, I'm going to attempt the same maneuver myself. I'll do that by going back to the Vehicle Tracking tab, and then I'll come over and launch my AutoDrive Arc tool. In fact, before I do that, notice this icon is actually split in half. If I click the lower half, I can go right into the bearing tool if I wanted to, or I can select from one of these preloaded bearings as a courtesy. I'm just going to select the Arc method to start the command. I will then pull down to the bottom of the library. I have also included the semi-trailer in this drawing. I'll double-click to select it. I will then zoom in and place the vehicle in the file. I'll rotate this such that it's aligned with the curb. I'll click Proceed. And I'm starting in the Arc method. That's fine. You do not have to use one method or the other. You can mix and match within the same path. So I'm just going to drive down to the island here and click. Then I'll come over and turn on the bearing method. I'm going to use the Pick Alignment tool to set my bearing. And I'd like to turn such that I'm parallel to this curb and gutter. I'll click to select the geometry, and then I'll drive the vehicle down into the open area and click. I'll use pick alignment again, and I'd like to back up parallel to this bay. I'll zoom in and click to park. I will then right-click and press Escape when I'm finished. Once again, using only a couple clicks, we can easily verify that a semi-trailer can park in this bay. Now, as long as we're here, feel free to experiment with some of the grips. By simply dragging my pass-through point, also known as a target point, I can easily adjust the path while maintaining the bearing. Likewise, I can easily adjust the target point on this end to ensure the vehicle can park in any of these bays. If you'd like to experiment further, see if you can create a path that allows the truck to park in these bays on the right side.